Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to the subject of Machine Design 1. We are right now solving a numerical on the design of hollow shaft. In the last part we have figured out the bending moment and the torsional moment acting on the given shaft. In today's session we are going to design the shaft. So friends, we need to consider the maximum principal stress theory or maximum shear stress theory. Let us consider both of them and let us see which of them is more suitable for our case. So in this case, we already have figured out this equation. You can refer to the earlier session where the formula are described, where this is the bending moment and this is the torsional moment, where C is the factor we have been given and outer diameter is what we need to figure out. So if I substitute the values on bending moment and other, which makes, if we solve this particular equation, we have only one unknown with us, that is the outer diameter, because the C factor is already given. We know that the maximum allowable value of the normal stress or any strength is nothing but 126.67 considering factor of safety. If I substitute the value back, I'll get the unknown D naught is equal to somewhere equal to 48.73 Newton. But that is not a preferred series, so let us go for the preferred series, which comes out to be 50 mm. So outer diameter, which is 50 mm in case, if the inner diameter, we already know this relation, and therefore with this value substituting we'll get D naught somewhere equal to 30 mm. So there we come out with the design part, and these are the design diameters for the given case considering maximum shear stress theory. Let's move ahead, and considering maximum shear stress theory for the given case, we have this expression with us where we can substitute the formulae, which becomes, but we already know that the allowable value is somewhere around 63.33 Newton per millimeter square. If I substitute this value back in this equation, we will get the value of diameter D naught, which is the only unknown in our case, somewhere around millimeter. Now we again know this relation that inner diameter and outer diameter is 0.6. We can substitute this value back, but before that let us go for the preferred value. So let us say for this particular thing 52 millimeter is the preferred value of the outer diameter. If we substitute it back, we will get the value somewhere around 31.2 millimeter for the inner diameter. So that is what the calculation part is all about. But now we have got two sets of values for inner diameter and outer diameter. So for the final selection, upon comparing two theories, final design says that the outer, the final diameter, which is outer one and the inner one, are based on this particular logic. Let us try to understand this. We know that the outer diameter is inversely proportional to the maximum shear stress, and it is inversely proportional to the maximum theory. So in that case, if the more the value of diameter I have, safer will be my component. If smaller the value I have, it will not be safe, and that's why I'll go for the greater values of the considered values, which we know that outer diameter is 52 millimeter and the inner diameter is somewhere around 30.2 millimeter. So this is what the final solution for my problem, which are safe. And that is how the design part is done for the hollow shaft. If there was a condition which was describing the rigidity also, we would have continued this problem to solve the rigidity concept also, and then accordingly we could have three sets of inner diameter and outer diameter, which upon comparison we would have selected for the final solution. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda. Thank you.